So, looking at L, how do we find L? Well, it's the square root of, perfect, 0.2 squared plus 0.3 squared plus 0.5 squared, which comes out to be how much? 616. You concur? Okay. Next easiest to find is probably R. R is found by doing what? Inverse tangent of 0.3 over 0.5, which gives us 30.96 degrees. Everybody concur? Get confused. Is that what you got for R? Okay. Here's the right angle, right? This is the opposite side, which is 0.3. This is the adjacent side, which is 0.5. So it's opposite over adjacent is tangent. Okay. Black that one out. T then is found by doing what? Inverse sine of 0.2 over 0.616, which gives us 18.95 degrees. Do you guys concur? You still look lost, Richard.
Nope. Yeah, I'm good.
Okay. T-bar, you're right. This one up here, which would have been 81.05? 71.05, yep, you're correct. Okay. Why are we doing all this? Because I told you to? I said you have to? Very good answer. What it's all about, let's say you have a piece here, a rectangular piece, and you need to drill a hole in it. But the hole isn't going to go straight through. The hole is going to go at an angle. Like that. Where it goes in here and comes out there on the bottom. Well, how do you drill that hole? You're not going to turn the drill to go at that angle. What you're going to do, you got your good old drill press here. You're going to tilt the table on the drill press, aren't you? You can tilt the head on a Bridgeport, yeah, but complicating things a little bit. You still can't do it all in one tilt. On your drill presses? You don't have any drill presses? Okay. Well, you do the same on the Bridgeport. You'd tilt the head on the Bridgeport, would be the same thing. You'd leave the table flat, and you'd tilt the head on the Bridgeport with your mill going through. Or you'd put a drill bit in the mill too, I guess. Either way, it's a tilt. That angle of tilt was this angle right up here, because this is going from straight up and down to whatever angle you're going through the material at. But the material can't sit on that table square. If I'm looking at that table, the material's not going to sit on it like this, is it? The material has to be rotated so the top of the hole and the bottom of the hole are straight up and down from each other. Does that make sense? That is this angle R. That's how much it has to be rotated to go from this side to being down the axle of the hole. So those two angles, R and T, are the two angles. T is the angle you'd have to tilt this, or the angle you'd have to tilt this. That's T. And R is the angle you have to rotate the piece in order, either there or you could measure R here, either one. The angle you have to rotate the piece so that you can go straight down through that hole. Does that make sense? This is all about setting up a part to drill, or for other things that we're going to be looking at over the next week. So let's look at let's say we have a piece that is 1 inch thick. This is our entry. This is our exit. Let's say that center to center here, this distance is 0.4 inches. This distance is 0.5 inches. What we have here is if we go center of hole to center of hole and just make a box out of it, is exactly the situation we've been dealing with. You're going from here to here. So that's your length of your cut, the length of the hole, how far you're going to have to drill in. That'll be important for calculating cut time and all that good stuff. This here's your angle of rotation. What? Which one? Yep, it will actually be all true. The angle of tilt takes into account the rotation of the hole after the hole's been rotated. Here, I think I've got a model back here somewhere. Look at that, right here. So here's your hole going in, here's your hole coming out, right? So you're sitting on the drill. So you're going to rotate it this way first so that this line here, the axis between holes, is perpendicular to the drill or the mill or whatever, right? So this is now lined up. Then you, what's that?
Why does the rotation matter?
Why does rotation matter? Because now when you tilt it, now this is straight above this.
Right, but no matter, just as long as the...
You couldn't keep it square.
You want, see I put this pen through the hole, you want that pen straight up and down. So you just drill right through it.
Right.
So you've got to rotate it first, so that now that when I do it this way, now I'm just turning that line is rotating in the plane now. So you've turned it so that it's in that plane that you're working in. So now you tilt it, and now that line's straight up and down. Or you tilt the head of the mill and it's going straight in and out. But you've got to get it rotated so that now we're in that plane of rotation.
To calculate the correct angle.
Yeah. Because the angle now is between this pen and this surface. Actually, it's this surface here, but is your angle of tilt to tilt the table. Does that make sense? Oh yeah. A bag of goodies back there. So like the length of the hole, you know, if you're looking at, you know, let's say you're running 300 RPM at a feed rate of 0.04, 40 thousandths per revolution. So now you can figure out how long it's going to take you to drill the hole. Now we're not going to do that quite, right now. Well, why not? Let's go ahead and do it. Find for me, this is T, not T bar, so it's the one up here. So it's going to be an inverse cosine, not an inverse sine. Find T, find R, find the length of the cut, and find the cutting time. You know how to find L, R, and T. L would probably be the first thing I would find. Cutting time might take you a little bit longer. But what we did is we took and we cut this piece out right here. The box is just the holes. We took that out of the whole piece. So it's drawn in the box here is just the holes. So this here is 0.4 right here. This is 0.5 and this is 1 inch. Does that make more sense? So step 1 is going to be to find our length, which will be the square root of 1 squared plus 0.5 squared plus 0.4 squared, which gives us how much? 1.1874 inches. Sound good? That works, yeah. I would go at least 3 digits when we're dealing with inches. Just, 3 decimal places when you're dealing with inches. R would probably be the next one, which will be the inverse tangent of 0.5 over 0.4, which gives us, what's that? 51.34. Very good. Look good? T then will be the inverse cosine of 1 divided by 1.1874, which gives us how much? 32.63 will go degrees. Angles, I usually just go to 2 decimal places no matter what. So our cutting time might take a little bit more work. 300 RPM times 0.04 inches per revolution is going to give us what? 12 inches per minute, right? So 12 inches per minute equals blank inches, 1.1874 inches in X minutes. Cross multiply and divide. 1.1874 divided by 12 gives us 0.098 whatever minutes times 60 seconds in a minute is 5.9 or 6 seconds. So you are correct. Well, you may have done the formula where your cutting time is equal to your length, 1.874, divided by 300 times 0.04. You get minutes, then convert it to seconds.
I converted I found out how many revs I needed. Took the distance and
Divided by the revolutions, and then divided that by the 300.
and then 300 divided by
Okay.
60 to get the revolutions per second, and then
Gotcha.
that out.
That works too.
Probably a long way.
Well, like I said, the way I did it here is one of the longer ways too. You could just use the formula. But I want to show you don't need the formula. You can just work out the units, tell you what you have to do. There are some little formulas you can use. But basically what we've done is all there. So I'm just going to leave you with what you have. Does the packet I gave you yesterday include page 395 to 397? Okay. Well, this is 1 through 10 there. 397. 1 through 10. Start out by doing the odds. If you have any questions, let me know. I'll do the rest if you need more. I'll have the answer key here. We can go through the answers on Monday. On Monday, we'll talk about what happens if you're not given the links, what happens if you're just given the angles. Which basically what I do is I just guess a thickness and I find links off of that. I cheat. Well, you can guess the thickness because it's all proportional. The angles are the same. The length of cut won't be right. You won't be able to get the length of cut, but all the angles will be the same no matter what your thickness is. So I just put in a thickness and go from there. Okay, that's enough for